equal to. Here we didn't know how much force we have to apply to raise the object to a height h. But the displacement is the object moves through a displacement h. That means it is the height. That's what the object is moving. Therefore, we can write f into displacement h. Okay. Now, just think, to raise an object, we have to apply a force which is equal to its weight. To raise an object, we have to apply a force which is equal to its weight. For raising this table, I have to apply a force which must be equal or greater than this weight of the table. And to raise this marker pen, I have to apply a force which is equal or greater than equal to the weight of this marker. Here, we are considering an object of mass m. Therefore, the weight of this object is W is equal to mg. So, we have to apply a force mg. Then force can be written as W is equal to mg into h. Therefore, we get the equation as W is equal to mgh. This is the potential energy stored in an object at a particular height h, mgh. Mgh is the potential energy stored in an object at a particular height. Now it is clear what's the difference between kinetic energy and potential energy. And then we are going to our next topic, law of conservation of energy. Next topic is law of conservation of energy. Law of conservation of energy. Law of conservation of energy states that energy can neither be created nor be destroyed, but it can be transformed from one form to another. That means energy can be transformed from one form to another. We are having different examples. When we are using an iron box, the energy we are supplying is electrical energy. And what's the output? The iron box gets heated up and we get heat energy. That means electrical energy changes to heat energy. And when we are using a light or simply a bulb or a tube light or a CFL, compact fluorescent lamp, etc., any light, we are supplying electrical energy and we get light energy as output. And when we are using a fan, we are supplying the same electrical energy and we get mechanical energy. Like the similar way for all objects or for all equipments we are using, the energy can be transformed from one form to another. But remember one thing, we cannot create energy or we cannot destroy energy. That's what we are saying in law of conservation of energy as energy can neither be created, it cannot be created, it cannot be made by any means, or it cannot be destroyed by any means. It cannot be destroyed, but we can transform one energy form to another. That's what called law of conservation of energy. Law of conservation of energy states that energy can neither be created, energy can neither be created nor be destroyed, but it can be transformed from one form to another. This is the law of conservation of energy. Energy can neither be created nor be destroyed, but it can be transformed from one form to another. This is the law of conservation of energy. In another way, we can say that total energy remains constant. For a freely falling body, the total energy of the body remains constant. That means that energy is conserved. For a freely falling body means a body which is falling under the influence of gravity alone. No other forces are acting on the object or body. The object or body is falling under the influence of gravity alone. Such objects are called freely falling bodies or freely falling objects. When we are considering a freely falling body, the energy of this body remains constant. That means potential energy plus kinetic energy remains constant. Then we can say that energy is conserved. Now we are considering the same freely falling body, and we are not having the derivation as proof. You study that derivation in the +1 topic, work, energy and power. Here we are going through only the theoretical part. The derivation is in your higher classes. Just consider a freely falling body from a height h. Considering m as the mass of the body and the object is at a height. This is falling downwards. And the first point is taken as A, and an intermediate point is taken as B, and the ground point is taken as C, and the ground point is taken as C. The object is falling from A to C, and it is falling under the influence of gravity alone. No other forces are acting on the object. The distance from A to B is taken as x. Then the total height is h, therefore remaining height is h minus x. Okay, now you have to find the total energy. Total energy at A, total energy at A, that is kinetic energy plus potential energy. Here at maximum height, velocity of an object is 0. At maximum height, at maximum height, velocity of an object is 0. Therefore, kinetic energy is equal to half mv square. V is equal to 0 implies kinetic energy is equal to 0. Then potential energy is equal to, we all know that the equation for potential energy is mgh. Here mass of the object is m, acceleration due to gravity g does not change g, and height is h. Therefore, potential energy is mgh. Then total energy is equal to kinetic energy plus potential energy, that is kinetic energy is 0 plus mgh. 0 plus mgh gives mgh. This is the total energy at point A. This is the total energy at point A. Now we have to find the total energy at B. Total energy at B. It is an intermediate point which is at a distance x from A and h minus x distance from C. Now I am going to find the kinetic energy and potential energy at B. Kinetic energy is equal to half mv square. Mass remains constant. Then m remains as m. But we have to find the velocity. That is, we have to find the v square value. By third equation of motion, we are having v square is equal to u square plus 2as. Since the object is executing free fall, that is dropped from a height, u is equal to 0, this term gets cancelled. Then v square is equal to 2 into, the object is falling downward, that is under the influence of gravity alone. Then acceleration is acceleration due to gravity. That you already learned in the chapter gravitation, that the acceleration acting on an object under free fall is called acceleration due to gravity. Here the object is executing free fall. Therefore, acceleration is acceleration due to gravity and can be written as g. Into s is the displacement of the object. Look, from A to B, the object is executing x displacement. Then we can write as x. That is v square is 2gx. Then kinetic energy can be written as kinetic energy is equal to half into m into, here we are having v square value as 2gx. 2gx. Then these two gets cancelled each other, and then we got mgx. Kinetic energy is equal to mgx. Now, moving to the potential energy. Potential energy is equal to, we are having equation mgh. M remains constant,